All right, hello Algebra 2 people. It's the start of a new unit and we're switching over to emphasis on graphing, which I think is pretty cool. I kind of like graphing. And what I'd like to do is we're going to be learning how to graph, in particular, square root and cube root functions. And we're going to use a technique that we've used before where we start off by graphing a parent graph, and then we'll see if there's any transformations that we need to apply after that. So let's start out with f of x equals square root of x. Now, I plead with you, put away your calculators, okay? Let's try this without calculators, and I think you'll find out it's actually easier. So anytime you're asked to graph something that you've never graphed before, a good thing to try is to make a table of values. Because then what you can do is you can put in some x values, get corresponding y values, plot those points, and get a general idea of the shape of the graph. Now, it's a square root function. I'm asking you to not use a calculator. So what are some values that you think would be easy to evaluate without a calculator? Well, hopefully what comes to your mind are some perfect squares. And because we're kind of limited with the spacing on our graph here, let's stick with perfect squares that are small. So actually the smallest number that we could do is actually going to be, I'd say 0. The square root of 0 is 0. Moving up, we could do the square root of 1, couldn't we? Square root of 1 is 1. And what else could we use? Oh yeah, we could use 4. 4 is a perfect square. Square root of 4 is 2. And what else moving up from there? Oh, 9. Square root of 9 is 3. And I apologize if you hear a vacuum cleaner in the background. My daughter's cleaning Reggie's cage. I know some of you know about Reggie. But anyway, so let's plot these points and see what we've got here. We've got 0, 0, 1, 1, 4, 2, 9, 3. Oh, I kind of got ahead of myself here. Why didn't I use any negative values? Could we have used negative values? Maybe like a -1 or a -4. Well, the answer is, if you take the square root of a negative, you're going to get an imaginary number. And imaginary numbers do not show up on our graphs. So we were restricted here in that we couldn't use negative numbers. And then we used nice perfect square numbers so that we could do them in our heads without the aid of a calculator. Now, because we couldn't be negative, our graph stops. And what we actually have is a parabola on its side. But because we don't have plus or minus out front, we just get the positive side of it. We don't get the full parabola. And that's a square root function. Now, we're going to be expected to graph this parent graph pretty readily, pretty easily. And then from there, do some transformations. We'll get to that here in a second. Now, something we haven't focused on in a while is, well, we focused on domain when we were talking about restricted domains. So we're still going to focus on domain, but we're also going to talk about range. Now, I would assume that from our previous section, you could get the domain of this without looking at the graph. You could see it's a square root function, so you've got that restriction of x needing to be greater than or equal to 0. But you can see that from the graph as well. Our lowest x value is 0, and it's going to go on up to infinity. So bracket 0 to infinity. We use the bracket because we can actually be at 0. Now, when we look at range, we're thinking of our y interval for the graph. What's our smallest y value? 0. So we're going to start at 0. And even though it's not going up as fast, as quickly as it appears to be moving to the right, it is going to continue moving up forever. And there we go. Hey, Silas, would you mind to let the dog in? Okay, thank you. All right, let's move on to cube root functions. Same idea. We're going to make a table of values. And, you know, again, we could use 0. Oh, we could also use 1, the cube root of 1. Well, yeah, let's go ahead and work these out. Cube root of 0 would be 0. The cube root of 1. Well, when you ask somebody what the cube root of a number is, you're actually asking what number times itself 3 times would get you that number. So what times itself 3 times would get you 1? Well, the answer is 1. Now, what else could we use? 4 and 9, they don't work because we're talking about cube roots. So yeah, 8. And a lot of you are getting really good at recognizing 8 as a perfect cube. Now, so far I've used positives, but would negatives be allowed here with a cube root? The answer is yes. Yes, it would. Whenever you take an odd root of a number, if it's negative, your answer is going to be negative. It stays with it. There's no restrictions in that regard. So let's also sneak in -1 and -8. And the cube root of -1 would be -1. Cube root of -8 would be -2. And I think we've got enough to make a pretty accurate graph here. So what we've got is we've got kind of a snaky sort of shape here, kind of a wiggle in it. We've actually seen this before. On Desmos, we've graphed some cubic functions, and they were going this way. But this one's on its side because it's the inverse of a cubic. So how I kind of do it is I draw half parabolas, like so. All right. And then domain. What do you think? Any restrictions on our domain here? We got negative infinity, positive infinity. No restrictions. It was an odd root, so that should be fairly apparent. Now for our range, be careful here. It's awful flat looking, but see how it's angled up here? It's going to continue going up forever. It's going to continue going down forever. So again, you'll have no restrictions, negative infinity to infinity. So ladies and gentlemen, these are the parent graphs. We're going to be expected to graph different types of square root and cube root functions, but these are the foundation from which we will build. All right, let's mix things up just a little bit. What do you suppose will happen when we take our parent graph and we multiply by -2? Well, we've actually explored these transformations earlier in the year when we did absolute value graphs. And I bet you have an idea that negative will do a reflection of some sort. And the 2 will impact the magnitude of our graph. In this case, it'll be a vertical stretch is what's going to go on. Now, you don't have to take my word for it. There's no shifting. This -2 doesn't shift anything. It does a reflection and it does an amplitude adjustment, but there's no shifting. So let's go ahead and just make our table of values. Because it's a square root function, I encourage you to use 0, 1, 4, and 9. That way you don't have to grab a calculator. -2 square root of 0. So do the square root part first. That's 0 times -2 is 0. Square root of 1 is 1 times -2 is -2. Square root of 4 is 2 times -2 is -4. And -2 times, square root of 9, the square root of 9 is 3 times -2 is -6. And you can already see, compared to up above, See how the values are multiplied by 2? It was 0, 1, 2, 3. Now it's -2, -4, -6. So their absolute value amount has been times by 2. But also they're negative now, and that's what that negative out front did. It's flipping this graph over. So let's make a graph here. So we've got 0, 0, 1, -2, 4, -4, 9, -6, and it is a parabola on its side, just like so. So compared to the graph above, it was a reflection across the x-axis, it flipped over, and it was a vertical stretch. So let's actually kind of summarize that just so we have that in our heads. It was a reflection, reflecting across x-axis, vertical stretch. Okay, let's try another cubic function. Again, we don't have anything, we're multiplying here. If we were going to be adding and subtracting, that would involve a shift or a translation of some sort. But we don't have that in this case, so let's just go ahead and make our table of values. And what values are we going to use here? We're going to use perfect cubes. And I'll go ahead and go from least to greatest here. We're going to use -8, -1, 0, 1, 8. And let's write these out. 3/2 cube root of -8. Again, I stress to you, don't use a calculator. I think you understand it better if you don't. The cube root of -8 is -2. Now what's going to happen is that -2, the 2's are going to divide out, and you're just going to be left with a -3. -3/2 cube root of -1. Cube root of -1 is -1. -3/2 times -1 is a +3/2. Now, just to make it easier to graph, I'm going to write that as a mixed number, so +1.5. -3/2 cube root of 0. Cube root of 0, 0. 0 times anything is 0. -3/2 cube root of 1. Cube root of 1 is 1. 1 times the -3/2. I'm going to write it as -1.5 to make it easier to graph. And here we are, 3/2 cube root of 8. Cube root of 8 is 2. The 2's divide out. You're left with a 3. Now notice, class, 3/2 was bigger than 1. And notice these values are bigger than what they were up above, the y values. So what this is going to do is this is going to make it a vertical stretch. 3/2 was bigger than 1. It's going to be a vertical stretch. So let's take a look at it. This is kind of embarrassing. Did anybody catch my mistakes up there? I started including a negative out front, so that's going to change some of these values. My negatives aren't supposed to be there. I honestly don't want to redo the video because I'm already this far in, but it's probably good for you to see some mistakes. So we're actually going to get a -1/2, a 0, and then a +1/2 there. Now we're back on track. I apologize about that. All right, so -8, -3, -1, -1.5, 0, 0, 1 up 1.5, 8 up 3. And it's kind of like half a parabola that way, half a parabola that way. And so it's the same graph from before, but just a little bit of a vertical stretch, And sorry I included a negative on those totally by accident there. Okay, now let's get to some translations. Oops, let me get this other hand out here. All right, notice our next two graphs, we've got some more things involved here. We've got some addition and some subtraction, as well as multiplication with our parent graph, okay? Now, what's going to happen is the adding and subtracting are going to be shifting left, right, up, and down. Now, before we do those, let's summarize all the different transformations that we can have up here at the top with a general equation here. So, depending on what A is, if A is negative, it's going to reflect over the x-axis. Also, if the absolute value of A, so meaning we ignore the negative, if A is bigger than 1, it's going to be a vertical stretch. And we haven't seen this yet, but hopefully you remember from earlier in the year. If the A, we ignore the negative, that's why I put the absolute value around it. If the absolute value of A is between 0 and 1, that's going to be cutting things. It's going to be makes the Y value smaller, so it's going to be a vertical shrink. So don't get too hung up on the absolute value. Again, that's just ignoring the negative. If there's a negative, you reflect your graph over the x-axis. All right, now let's move on. The plus k is the most intuitive one. If you're adding k at the end there, that's going to shift the graph vertically. It's going to be an up-down shift. And then the most intriguing one that we've explored in the past is inside the operation, whether it be an absolute value, a squared, a square root in this case. If you add or subtract within that operation, a curious thing happens. It's going to be a shift horizontally. Shift horizontally, and it's opposite of what you'd think. It's the opposite of what you think. So if it's minus 3, you're actually going to move it to the right 3. If it's plus 3, you would move it to the left 3. It's a little bit counterintuitive. Now, it doesn't matter what kind of operation you're doing. These transformations are going to be the same throughout functions, okay? Any type of function you're doing. So for a cube root, it's going to be the same. All of those stretches, shrinks, all those transformations apply the same way to a cube root function. Okay, so here's the method we're going to use. When we come across a function that has translations, it has addition and subtraction, what we're going to do is we're going to do a non-shifted graph first. Non-shifted first. So the non-shifted graph would be y equals 3. 3 doesn't make it shift. It's a vertical stretch, so it doesn't shift it. But we're going to do 3 square root x. We're going to get all the points for 3 square root x. Then each point we're going to do a shift. And that shift is going to end up being not right 2, but left 2, down 4. So we'll start out, we'll get our table of values. Now since we're using a square root, since it's a square root, we'll use 0, 1, 4, and 9. That way we don't have to grab a calculator. 3 square root 0 will be 0. 3 square root 1 will be 3. 3 square root 4, square root of 4 is 2, times 3 is 6. 3 square root 9, the square root of 9 is 3, times 3 is 9. And let's graph them. 0, 0, 1, 3, 4, 6, 9, 9. So that 3 really did stretch it out, didn't it? Okay, now we're going to take each point and we're going to do a shift. We're going to shift each point. And I'll make an X after I shift it. That way I can keep these points separate, because if you don't use a different way of recording the points, you can get them confused rather easily. So we're going to take each point and go left 2, down 4. Left 2, down 1, 2, 3, 4. Left 2, whoops, already got that one. Left 2, down 1, 2, 3, 4. Left 2, down 1, 2, 3, 4. And then, sorry, slide that up there. We'll go ahead and connect those dots just like so. And I'll put a fat end point right there. And there you go. Now, I'm just realizing on the other page, we didn't talk about domain and range after we got our graphs there at the bottom. So we should probably go back and remedy that. Our domain for this graph, because it was flipped upside down, our domain's a little bit trickier. Instead of being like up above, bracket 0 to infinity, that's positives, isn't it? Well, for our domain, we're still going to have positives, bracket 0 to infinity. But our range is where things get curious. What is my, because interval notation, you want to start with the smallest value first. The smallest value of this graph, the y value, the smallest amount is going to be negative infinity. It'll start at negative infinity. And what's your biggest y value? 0. So it's a little bit different. Up above, when it was going upward, bracket 0 to infinity. Going downward, negative infinity up to 0. 0 is the biggest you can be. And for this cubic function, arrows going in both directions, no restrictions. You may get an idea that with cubic functions, it's always going to be negative infinity to infinity, and you'd be correct. All right, now let's go back. We shifted this graph left 2, down 4. Let's talk about our domain. Smallest x value of this graph is negative 2, and we can be it. Biggest is infinity. For our range, our smallest y value is negative 4, and we're going up to infinity, just like so. All right, one more, and we'll call it good here. I would encourage you to pause the video and try this one out yourself and see if we concur. Maybe, you know, figure out your x values, then see if we match, then see if from there, see if our graphs match. But try this one out on your own as much as you can, and then double check with my work. All right, so I'm going to do the non-shifted version first. The -5/2 is not a shift. It's going to be a reflection and a stretch because it's bigger than 1. But we're going to incorporate that. What we're going to ignore is the -2 and the 3. Because it's a cube root, we'll use -8, -1, 0, 1, and 8. -5/2 times the cube root of 8. Well, the cube root of 8 is going to be a 2. The 2's will divide out, and we'll get a -5. Oh my goodness, I'm already at it. I apologize. Cube root of -8 is a -2. And when the 2's will divide out, but a negative times a negative is a positive. Boy, you got to watch me on these cubics, I tell you what. Cube root of -1 is -1. Negative times a negative is a positive 5/2. But 5/2 is a little tough for me to graph. I'm gonna write it as 2.5. -5/2, cube root of 0. Cube root of 0 is 0. 0 times anything is 0. -5/2, cube root of 1. Cube root of 1 is 1. We get -2.5. And then finally, -5/2, cube root of 8. Cube root of 8 is 2. The 2's divide out, we get a -5. And then we plot those coordinates. -5, -8, 5. -1, 2.5. 1, -2.5. 8, -5. Now notice, because there was a negative out front, instead of this graph going like this, it's been flipped over, so it's going like that. 5/2 is bigger than 1, so it stretched it out. Now we're going to take each of these coordinates and we're going to do a shift. Right 2, up 3. Right 2, up 3. Right 2, up 1, 2, 3. So we're halfway there. Right 2, up 1, 2, 3. Right 2, up 1, 2, 3. Right 2, up 1, 2, 3. And then connect those. Think of it as like half of a parabola, and then the other half of a parabola, like so. And we have a pretty good graph there. All right, now for our domain and range, we did have some shifts here. We shifted, right 2, up 3, so that may impact our domain and range. What do you think? Take a look at those arrows. No restrictions whatsoever. I'm going to go to the left forever, to the right forever, up forever, down forever. So we get -infinity to infinity for both of those. All right, class, so there you have it. I don't have the assignment in front of me right now. I'm at my house, and I had recorded this video on Friday, but it didn't have any sound, so I think my microphone doesn't work anymore. But so I'm here at my house. I don't have that assignment handy at the moment, but I'll have it on the board for you tomorrow. Also, it'll be in SIS under the announcements. So hopefully this helps out. practice this, okay? Practice this. Really get a feel for doing the non-shifted graph first, then doing the shift. Also, focus on getting those, being comfortable with those domains. It's been a while since we've done range, and that might be an area of concern. All right, thanks for watching. Have a great day.